Because of the placebo effect, which was doing what to them? Yeah. Yeah. Just the thought of improved performance helped them improve, right? It had nothing to do with the substance itself. So we call that the placebo effect. Why would we need a placebo in an experiment, though? We're comparing like a medication. Why would it be important to have a placebo and then the medication? Side effects? Yeah. What other things can you think of?
It's like the placebo is the control group in the actual drugs experiment.
Yeah, it gives us a control and experimental. Why do we need the control? Why do we need that placebo controlling? Julia, what do you think?
To see if it like actually affects people or if it's just a
To see if there's an actual effect of the medicine or is it just mental, right? So, so similar to the video, Mr. McBurney, I don't know who that is, wants to use a beverage to test the effect that caffeine can have on heart rate. Here's his plan. He's going to measure the initial pulse rate, give each student some caffeine, wait for a specified time, measure the final pulse rate, and then compare initial and final. What are some problems with the plan? Like, what other confounding variables will be sources of variability in their pulse rates? What other things could be at play here? What you got?
anxiety or anticipation of the results.
Yeah. Anxiety, anticipation. That can affect your pulse rate, right? What's something else that can affect your pulse rate?
Just moving around.
Yeah, general movement. Before and after the experiment, during the experiment, that's going to change your pulse. What else could change your pulse?
I mean, it says students, so like if they have like a PE class, obviously that's like more elevated activity.
Yes. Well, like let's say we were doing it with you guys walking in the room right now. Okay? So no matter where you came from, you're coming in. What are things that could be in your bodies or about you that could affect your pulse rate? Like we said, movement, right? What were you going to say, David? General weight, right? Weight and height, that affects pulse, doesn't it?
Would that be included in like the original pulse rate?
It could be.
Thinking, like, the effects of
The effects of caffeine may be changed because of bigger body mass, or smaller body mass. Other things?
caffeine?
What about caffeine? I'm giving you caffeine in the experiment. So,
Previous caffeine.
like in the day? Like if this is the first dose of caffeine you've had all day, is it going to affect you differently than if you've already had Dutch Bros or Starbucks or multiples? Yeah. Your caffeine, what's the word? Caffeine. Intake, thank you. I was going to say sensitivity. That's what it is. I can't drink too much caffeine because then I get jittery, right? Some people do, some people don't. Doesn't matter. So all these things are at play that can affect heart rate that he is not measuring in his experiment, right? So we have to be very careful about those things. And like I said yesterday, what do we call these?
Confounding variables.
Good. Confounding variables. Just a rehash of the word. A good experiment is going to try to limit them, control them as much as possible. Are they ever going to eliminate them all? Nope. It's not going to be possible. All right. Now, if we go back to our list, we're not going to have time to propose a solution for every problem, but let's think about this. Can you think of a solution to any one of them? What we could do in our experiment to control for that?
Have them sit down during the duration of the experiment?
Okay, so in general movement, maybe make sure everybody stays seated. That might be one solution to that piece. What else?
We asked them not to have any caffeine before.
Uh-huh. What about anticipation? Huh?
That's all in their minds.
It is all in their minds. So what could we do about, is there anything we can do about that in our experiment? Is there a way we can use placebo effect in our experiment to take care of that anticipation? What do you think?
I do like for placebo effect, but make sure to like discontinue with class and maybe not tell them when it's gonna be, so
Uh-huh.
they don't have, they're
Yeah.
like looking at the clock. And
Not make
getting
them
worked
freak
up
about it.
over it.
Yeah, that could work for the anxiety. What I was thinking was like, give them, because there's caffeine-free Coke out there, and there's real Coke, right? What if you just say, I have cola? Some of you are getting caffeinated, some of you are getting non-caffeinated. That takes away that idea of, oh, you're about to give me caffeine, I'm going to get worked up, right? You don't know if you are or not because it's placebo. They don't know, right? That is a form of blinding. So like if I give her the Coca-Cola, she doesn't know which one she's getting. I would know, but she doesn't, right? That's a blinding effect, and that helps with placebo because it helps to kind of rein in any possible anticipation or anxiety embedded in the experiment. All right? So let's design an experiment to test the effect that caffeine has on the heart rate. Now, it's not going to be perfect, but let's think through this. Let's say we start with 30 students. All right? How many treatments do we have in this thing? We have 2, right? Because we need a control and then the actual treatment. What's our control in this case going to be? A caffeine-free cola, right? And then a caffeinated cola. So we're going to have and then caffeine. How do we get them into the groups, though? There has to be the random assignment piece. This is what makes it an experiment, right? So we start with 30 students. We randomly assign them to 2 groups. This would be what, 15 in each group? I guess we should put in here somewhere at the beginning before we randomly assign, we would take their initial heart rates. Okay. And then at the end, we would take the heart rate after the treatment and compare to the initial heart rates. Alrighty, okay? Okay, so we're just kind of getting used to designing experiments. This one is called a completely randomized design because all we did was random assignment, right? There wasn't anything weird or special about it. We just randomly assigned to 2 groups. There are other types of experiments, and we're going to do those on Monday and Tuesday. I'm going to show you examples of those. But completely randomized is when it's just this basic idea. All right, so let's look at this. Control group. We talked about this. Why do we need a control group? You use this to provide a baseline data for comparison. If I don't have a comparison group, I can't say it's making any difference, can I? You have to have a baseline for comparison. That's why we need control groups. Sometimes the control group is the placebo group. depending on the experiment. Sometimes the control group is the old medication when you're comparing it to new medication. All right? Just depends on the scenario. Blinding is when the subjects, what are subjects? Do you remember? People. Okay, people, experimental units. When subjects, this is when it's single blinded, and or the experiment researcher, this would be double blinded, who interact are unaware of what treatment is given. Okay? So sometimes the researcher knows exactly which treatment they're giving the individuals, but the subject does not know. Okay? Sometimes they do double-blinded experiments, especially in pharmaceuticals. When you read those studies that always say double-blinded experiment because they don't want any kind of bias built into this result, right? Double-blinded would mean like the researcher would hand off the treatments to a third party, and they would label them A, B, C, D, or 1, 2, 3, whatever. And then they would assign those treatments to the subjects, and later, after the experiment is done, they would find out which treatments were which. Does that make sense? Mm-hmm. So it's when the researcher and the subject don't know, that is the double-blind thing. All right, and then what we said, the placebo effect, is when a fake treatment called the placebo actually works. We know it can happen, but sometimes that's our control group. We use it on purpose to help it filter out any different changes. Now, the random assignment piece. We did this with samples, but when we do it with experiments, it's going to follow the same structure. You have to label or number the units. Could be subjects, it could be flower pots. I don't know, whatever you're experimenting with. You have to number them. Then you randomize them. You can use the RNG, or you can use pieces of paper. Select somehow, and then repeat as needed, right? We've done a lot of RNGs. So I'm going to model on our example down here, I'm going to model a pieces of paper randomization. So you choose the one you want. Either one works, all right? Number 3, key elements of an experiment. There's 4 things you have to know. 2 or more treatments would give us a comparison. If there's no comparison, there's no treatment. Or experiment. Got to have comparison. You have to have random assignment. All right, look at this definition. Whatever the word is, it says is keep all the other variables besides the treatments constant. What do we call that? Any idea? It starts with a C. Control. Yeah. Control. Control is an effort to try to minimize confoundings. Yes. Okay? Minimize confoundings as best we can. And then lastly, the word is replication. What does it mean to replicate something? Do it again. So you would know that if I just did the experiment with 2 people, one with placebo, one with the actual treatment, is that enough for me to have a result? No, you intuitively know that. So replication just means you have to do it multiple times to have some kind of result to even talk about. All right, so replication would be like, hey, I used 30 subjects, or I used 1,000 subjects. That's where the sample size comes in. Does that make sense? So make yourself a note if you want. Control, comparison, random, and replication. So it's 2 C's and 2 R's. Those are the things you have to have for a good experiment. Next week, I'm going to give you an activity where I'm going to give you descriptions of experiments, and you're going to pick these pieces out. That's going to give you points back on the quiz that we're all stressed out about. All right? That's for extra points to put back on that quiz. But this is also really good practice in analyzing experiments. All right? And one of your projects, it won't happen until next quarter, but you're going to design an experiment. You're going to want to make sure it has these elements. All right? So let's look at this. A group of researchers in Africa find a creative way to protect cattle from lion attacks. They paint eyes on the cows' rears. To determine if the treatment is effective, they randomly assign the cattle to one of 3 treatments. Eyes on their rear, cross marks on their rear, or there's nothing. After 4 years of roaming the plains, the cows with eyes saw no deaths, the cows with crosses suffered 4 deaths, and the cows with no marks suffered 15. Explain why it's important to have a control group that didn't even get a mark on their rear. Why do we need that? Comparison, right? We need a baseline of comparison. This group provided a baseline comparison to, now here's where we get specific to the context, to know how many cow deaths are typical with no influence, right? We don't know how many deaths is normal. That's why we have to do it. Suppose the researchers had 1,200 cows. Describe how to randomly assign the cows to the treatments, all right? This would be a terrible way to use pieces of paper, but I'm going to show you how to do it, just for example's sake. All right, we're not designing, we're not doing that little flowcharty thing. We're explaining how do I randomize which treatment they're going to be in. Okay, there's 1,200 cows, right? So the first thing I have to do is number the cows or label the cows 1 to 1,200. Oops. I mean, it's much better if a group of 30, but 1,200. All right. For example's sake, so I'm going to put 1 to 1,200 on separate pieces of paper. Put them in a hat. Shuffle the papers. You got to say shuffle or mix them up, otherwise it's not really random. Shuffle the papers. Then I'm going to select. Okay, so there's 3 groups, right? So how many are going in each group? 400. So I'm going to select 400 different papers. And assign those cows to, which treatment do you want to start with? The control group. To no eyes. Do I want to put those papers back in the hat? No. Do not replace. Then what would I need to do?
Repeat for the other 2 groups.
Yep, select the next 400, right? Repeat, process. The next 400 would go to, what do you want, crosses on their butt? The crosses group. And then the final 400 would be the eyes group. All right, so that's how you would list out the process if you wanted to use pieces of paper and a hat. You choose which way you want to do it. This is much wordier, isn't it? Now, what is the purpose? This is a great multiple choice question. I've seen College Board do this. What's the purpose of randomly assigning treatments? Terrible color. Why do we have to randomly assign our treatments?
So it's not biased.
So it's not biased is all I heard. What did you say?
To eliminate
Well, we can't ever, be careful, you can't ever eliminate bias, all right? It's easy to say that, but we can't ever eliminate it. We want to reduce it, all right? So to reduce bias, yes. But the definition, you know how their College Board definitions are a little tricky, right? So I want to get this right. I want to give it to you. Here's how it's how it's stated. The reason we randomly assign, it says random assignment creates roughly equivalent groups by balancing out other variables. In this case, like cow size, right? Random assignment creates roughly equivalent groups by balancing out other variables. The size of the cow could be a factor, right? And whether they're killed or not. You don't want all the big cows ending up in one group, so you randomly assign so they kind of get evenly distributed, right? Other factors of the cow, the color of the cow, right? The purpose of random assignment is to create roughly equivalent groups based on all the other variables that potentially could affect the outcome, all right? Then, create an outline showing a completely randomized design. This is where you do the flowcharty thing, all right? But you don't have to write out all the steps of random assignment. You just write random assignment. For instance, let's do this. So, we're going to do 1,200 cows. We start there, all right? And we're going to randomly assign. But this time we have 3 groups, don't we? And we're going to put 400 no eyes, 400 crosses, and then 400 eyes, right? And then what is it that we're going to be comparing at the end of this? The number of deaths, right? We good? So then what's the explanatory variable on this guy?
The crosses.
The butt markings, right? Explanatory variables. We don't know. Is it, if we mark their butts in some way, is it going to reduce death? So that's explanatory. So I'm just going to mark that. Explanatory. What is the response variable here?
The number of deaths.
Number of death. So notice where they fall when you diagram an experiment. This is just a completely randomized, nothing fancy, no weirdness going on at the initial stages, which you'll see more of that next week. All right?